Hello everyone, in this video we are going to see about the divide and conquer algorithms, and one such algorithm is the merge sort algorithm. This algorithm uses the divide and conquer technique to solve the problem, and is also use the method of recursion. Okay, so let us see first what is the merge sort. As another example of divide and conquer, that means we have seen before the earlier classes about the minimum and the maximum. Finding the minimum and the maximum of a given array, that is one of the example of divide and conquer technique. The next example for this divide and conquer is the merge sort. Okay, it is investigate a sorting algorithm that has a nice property that in the worst case its complexity is order of n into log n. This algorithm is called merge sort. Okay, let us see how the merge sort works. Merge sort describes the process very succinctly using recursion and a function merge, which merges two sorted sets. Before executing merge sort, the n element should be placed in the array A of 1 colon n, and the merge sort 1 comma n causes the keys to be rearranged into non-decreasing order in the array A. So this is what the merge sort algorithm does. Let us see how the algorithm works. Before that, let us see with an example. This is a list of elements given to sort, and as we are following a divide and conquer technique, let us divide the element into first equal sets. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements are there. So we divide this element first into the half, which is from the first to the fifth element. Okay, and now after dividing this 5, again we subdivide into further elements by 3 and first 3 and the 4 comma fifth element. Okay, so now while dividing this element from 1 to 3, we again further divide into the elements 1 to 2 and by 3. This is all by the formula n plus 1 by 2. That is low plus high by 2. So now there is this bar in between the numbers says how the elements are divided, how the array is divided into multiple subsets. So now this is one subset 285 comma 310, and next is 179, and 652 comma 351 is the next subset. Now let us first try to arrange the elements in this order. Okay, so now we'll first arrange this particular subset, and then we'll follow the recursion to do the arrangement in the next subset. So okay, let us first concentrate in the first subset. So now we are having the set as 285 comma 310 is the first set. That means here we are having 310 as the element 1 and 285 as the element 2. So now it is not in order. While checking the element, it is not in order. So we exchange the values between the two subsets A of 1 and A of 2. So which is 285 and 310. Afterwards, this subset is merged. That means it is in order. Now we have to merge the thing with the next subset. Next subset is the element 189, which is the element A of 3. Okay, so when you combine this 285 comma 310 as one set and the set 179, we'll check the first element and the element of the next subset. So this is higher and this is lower, so exchange the value with 179. So 179 is placed in the first position. Afterward, then this 310 and 285 is checked, and then this 285 is lesser than 310, so it comes in the second position, and then 310 comes in the third position. Now the subsets A of 1 comma 3 is now sorted. Okay, and now we have next subset 652 comma 351. By checking, this is not in order, so this is exchanged and the list becomes 351 comma 652. Okay, so now this list is individually sorted and this list is individually sorted. Now we have to combine this subset with this subset, that is A of 1 is to 3 and A of 4 comma 5, in such a way that while combining these two sets, the set became in the sorted order. Okay, so now consequently we keep on checking with the elements of the first subarray with the next subarray, sorted subarray. Okay, so 179 is compared with the elements of the next array. Among these both these two, 179 is smaller, so it get the first place. Then 289, it is checked with the element these two, again it got its own place, 285. And then 310 is lesser than 351, also 652, so it is put in the same position. Okay, and then 351 compared to 652, it is in order, so it is copied as it is. So now the first biggest subset, which is the element from A of 1 to A of 5, is now in order. Now we have to repeat the procedure in recursion to do the sorting in the next subset also. So how the list goes, now we are having the element as 423, 861, 254, 450 and 520. This has to be now sorted. So how to sort this? Now we have to check with the, again as we did in the previous sets, we have to divide into two elements, two subsets. So now the set becomes, and then afterward it is again divided into two subsets. So 6 comma 7, that is A of 6 comma 7 is one subset and A of 8 is another subset. So combining A of 6 and A of 7, they are in order, so they are just merged, 423 and 861. And then when it is combined with the A of 8, which is 254, it has to be rearranged. So this is the next scenario. So now this 254 comes this position and 423 is arranged here. Okay, and then 861 is in the position. Now this list is arranged in its subset, and this list is, we have to again arrange. So 450 and 520, they are in order. Now we have to combine this subset with this subset, so that when combine these two, they are in order. So checking with the 254 and 450, 520, it is in order. With the 423, it is lesser than 450 as well as 520, so it is in order. Then checking with the 861, this is not the case, so we have to exchange the value of 450 and 861. So the position of 450 and 861 has changed. And then combining, checking with this 450 and 520, it is in order, so 520 comes in its position. So this is the way. Now this element itself is in order and this subset is in order. Now we have to combine these two subsets in order to find the final merged set. So as we did in the previous set, we have to check the first element with the elements of the remaining set, and you have to find the position of the first element. Then you have to go for 285, then we have to check with the next set. Here we can see 254 is lesser, so these two elements are interchanged. So likewise we have to combine all the elements one by one by checking the positions whether it is less than or greater than, and finally we arrive at this solution, the final sorted list. Now let us see how the algorithm works. First we have to divide the problem into sub problems, so the algorithm merge sort works. So the merge sort starts from low to high, that means it will combine the element from the lower to the higher order. So the elements are sort, the elements are from lower index to the higher index, and we have to check if low less than high, that means as long as there are elements, you have to divide the problem into p sub problem. That means you have to split the problem into multiple subsets. How to split? Use the formula. So mid is equal to low plus high by 2, so you have to find the mid position by this average formula, and the mid position is found out. Once you find the mid position, the merge sort has to be applied from lower to mid, and then again it is recursively it is applied to mid plus 1 to high. That means one subset is fully formed here and next big subset is fully formed here. Then we have to combine the solutions of these two subsets to get the final merge set. So that is done by the algorithm merge low comma mid comma high, because low is the list first element, first array's lower index, and mid is the middle index, and high is the higher index. So it has, the algorithm merge has to combine the solutions from both the sets low comma mid and mid plus 1 comma high. So now let us see the next algorithm, which is the merge algorithm. In this merge algorithm, we are going to merge the two subsets in order to arrange the elements in the final sorted list. So we have to set the index as low as h, and we copy the same value of low into I also for some reason to preserve the value, and j is equal to mid plus 1. So the loop continues like this while height less than mid and j less than equal to high. That means as long as the subsets 1 and 2 remain, we have to repeat the following if conditions. So what is the condition? If a of h is less than a of j, then we have to copy the value of a of h into b of I, which means you have to copy the lower value to the B array, and we have to increment the H index. Otherwise, we have to copy the lower value which is J. Okay, so either H may be, if this is true means H index is low, if it is false means J index is low. So whichever is low is copied to the new array B, and then the index is incremented as H is equal to H plus 1 or J is equal to J plus 1. So either case, now the elements are sorted in some order. So we have to, in one position it is sorted, so we have to increment by 1. I is equal to I plus 1. Okay, so now this part of the algorithm checks the order of the element in the two consecutive subsets in order to get the new merged proper set. And now the algorithm follows this way. There are some remaining elements in either in the first subset or in the next subset. So whatever it may be, the remaining element has to be copied. So how to copy? For k is equal to j to high, we have to copy the values of a of k into b of a, remaining values from the first subset. Or for h is equal to, k is equal to h to mid, we have to copy from the second sublist. So whichever list may be longer, because the subset may be in different length. Okay, so whichever the values is remaining, we have to copy the values of a of k into b of I. That means now b of I contains the ordered set of numbers. So now the for loop for k is equal to low to high, it copies all the values from b of k array into the a of k array. So this a of k will contain the final completed merged sorted list. That's all the concept of divide and conquer algorithm, which uses the recursion technique to solve the problem of arranging the elements using the merge sort algorithm. Hope it is easy to follow, and thanks for watching.